Okay, now let's start with the bouncing ball. First of all, I'll create a new action right over here and name it bounce underscore floating, because first we will see how it looks like without any spacing. Enter and delete all these keyframes as we don't need this. Keyframes deleted. We'll move back this ball right at the center by Alt G. Clear location, now clear rotation as well. Just zoom in a bit, zoom out, sorry. Bring it right here. Okay, I'll bring back the widget. It's good. Right here. Okay, at frame number 1 we got a keyframes right here. Now I'll add 10 frames and move to frame number 11 and Control or Alt G to clear location. So we're back right at the origin, and I'll just rotate it by 90 degree. Okay, that's it. Plus, now I'll just add 8 frames to it. Okay, I'll just adjust these windows so that we get most of the views over here. Okay, right there. Okay. Now we have moved to frame number 19. Just bring up this ball right here. Okay. See, as we have chosen interpolation as constant, we can block out the animation quite easily. If we have kept it like interpolation as linear or Bezier, it would have been a bit tricky. So constant is good. Okay, now frame number 19, the ball will bounce up to this. Then add 8 more frames. Before that I'll just rotate the ball by another 90 degree. Yes, done. Then add 8 more frames and move to frame number 27. Alt G to clear location. Rotate another by 90 degree. Yes, that's it. Add 6 frames now. See, it's progressing like 10 frames from here to here, from here to here 8 frames, from here to here 8 frames. Now from here to here it will be 6, then 5, 4, 3, 2, 1, so on. Okay, let's see how much we can do. Okay, right there, right there. Okay, it won't. You may adjust these values according to your taste, but keep it simple right now. Rotate it by another 90 degree. Okay, done. Now add 6 more frames and bring back this ball to its origin. Alt G to clear it. Oh, I haven't okay, now add 5 frames. Just let me see, it's okay. I have to rotate this by 90 degree. Okay, done. Now add 5 frames rotate it by 90 degree. You may change the rotational values with the different values rather than just 90 degree each time, but I'm trying to keep it simple right now. Just 90. Okay. 10, 8, 8, 6, 6, 5, 5 plus 5 again. RG. Plus now 4 frames. Add 4 more frames, bring it down to center, rotate it by 90. Now add 3 frames. Okay. Rotate it by further 90. Well, I'll just keep it as 45. Plus 3. RG. Now add 2 frames. Okay, to see how it's increasing. We'll just adjust this window size, not window size, the viewport size. Okay, now just here. Okay. Rotate it by 30 degree. Okay, and this is 10, 8, 8, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2. We'll have to add 2. That's 2. RG declare rotation. Okay, done. Now just add 1 frame and just bring it right here and just rotate it by like 10 degree. Just add another more RG, rotate it by 5 degree. Okay, that's it. Okay, we're done. Now let's review the animation. Okay, it's I'll just make it 70 frame animation. Just N home. Okay. Okay, now I'll just change the interpolation to linear and let's see how it looks like. Okay, you see it's looking like a very floaty kind of ball, like it's not influenced by any gravitational pull, or it doesn't look like it's having any weight. so that's a simple bouncing ball without any particular space. So even I change this interpolation to Bezier, nothing much will change because it's all a sine wave kind of thing. Okay, one more thing. See, from here to here it's 10, from here to here it's 8 frame, from here to here it's again 8 frame. So basically this crest is the mid position between two breakdowns. You can say the crest are all the extremes, and the contact position can be taken as a breakdown, or the passing position. Okay, so from here to here it's 10 frame, from here to here it's 8 frame, from here to here it's 8 frame, from here to here it's 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. Okay, that's it. Now let's review the animation while this curve is in Bezier. So nothing much change in this. Okay, even I change the linear. So to make it more realistic, I'll change this curve. I'll just change this curve a bit, because ball doesn't bound in this particular fashion like in sine wave form. So before that, I'll do one thing, just a minute. Okay. Bounce floaty. Okay, make it a fake user. Now I'll create one more action and name it bounce spaced. And make a fake user here too. Okay, good. Now I'll just change this handle type from auto clamped to it's in under auto clamped. I'll change it to vector. So as soon I change it to vector, you see a sharp change over here rather than a smooth curve at this position. And I'll change all this to vector. Now let's review the animation, how it looked like. Still better, but not good enough to. So see the difference between the floaty and the spaced. Okay, what I'll do, I'll just go back to bounce floaty action and enable this option. This is called create snapshot. Okay, when I move back to bounce spaced, I can see what was the previous state of the curve. You see smooth sine wave, smooth, but we have changed under bounce spaced action to vector at this particular contact position, or the breakdown position, or the passing position. But still it doesn't look like it's having a weight of its own. Still floaty, very much floaty. So now, rather inserting a few keyframes between, okay, I'll just make these keyframes as extreme so that we don't get confused. So this is nice little feature here that we can change the color of these keyframes according what kind of keys are there, like you know they are breakdowns. Okay, so the pink one are the extremes and the blue one are the breakdowns. Okay, now rather inserting a few more keyframes in between the extreme position and the passing position, that is the breakdown, we will manage with these handles of the Bezier curve, and we can still get this kind of curve we have seen here. uh, this nice little, okay, I'll change this to linear. See, a nice a kind of a curve, but not a curve, because two keyframes have been like joined by a straight line rather than a smooth curve. It still looks like a spline curve. So we can achieve that with the help of those handles and a Bezier curve. I'll just grab this handle and drag it towards this, so it becomes like this. I'll show you how. G N, okay, so that you can see what keys I'm pressing right here. G X, and I'll try to bring this handle right at the top of this passing position. Right, G X, okay, right there. You see how much we have moved these curves from this position to this. Means it's staying at the very top for few of the frames, then it's coming very fast. Okay, for the rest of these handles we'll do the same. Bring back. Okay, for the left hand handle, we'll just not bring to this position. Right at this position we'll keep a little short. I'll tell you the reason why. A little, just okay, that's it. Let me do it real quick. Okay, just okay, now let's see. Oh, that's perfect. Now you can see that it's bouncing like it's having its own weight. See how much this handle can improve your animation. So just what we have done is this. Still we can tweak these handles, these vector handles, and bring it very close to this particular curve, so that it becomes very straight, and just bring it so that it doesn't form a curve. Still it's like looking like a curve. You can see, so it's maintaining it a curve. So we'll just bring this handle right here, and Okay, just done. Like, okay, we're done with this. Now let's review that. Okay, perfect. Okay, now I'll just flip-flop between these two actions, the floaty and the spaced. See, you can see the difference. So this is with no weights. This is, you see the difference, right? Okay, now let's stop this, and now let's move to this ball will roll plus bounce. Let's see how we can do this. Save this. Let's go back to spaced. Sorry, floaty. Let's move to frame 1. And just drag this ball right here. Okay. What I'm doing, actually, I'm just like in the previous bouncing thing, we are just dropping the ball from here to here. Now we'll just bounce the ball from here, and it will bounce like this, and like go from here to here, from left to right. And let's move to very last frame. Okay, now just move this ball right here. Okay, now let's review. Oh, sorry, we have done a mistake over here. Before that, I should have changed this. Let's see, we can delete that effect. Before that, let's review this. Okay, it's looking very floaty. But I'll just keep it as. Okay, you see, it's coming in a form of it's like it's floating in a space, outer space, without any under the influence of any gravitational pull, because it doesn't have any weight of its own, or rather its weight is it's not influencing its movement. Now for the same bounce spaced, I'll just add another action and name it bounce roll spaced. Okay, now frame 1, I'll just move this ball right across this place, and for the very last frame, I'll move back this ball right over here. Okay, now you see this animation right now. Add a fake user. Now let's review the animation. You see the difference? See, no, not this one. See this one without any spacing, and it looks so floaty. Just remove the widget. And this one with the space thing. Now you see how much you can improve your animation with the spacing thing. Okay, now we'll see the spacing thing more clearly with this thing. Zip, 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 zip. don't know if it's visible right there. But you can see this spacing thing, like when it's coming down, it's coming very fast, and this the spacing is increasing, and at the very top it's like very little space between two keyframes. So, and when it's descending, it's very much apart. Like, and one more thing you should notice, that this particular keyframe here and this one should be lower than this one. For example, here this one is lower than this one, this one is lower than this one, this one is lower than this one. And the reason is because when a ball is bouncing back, it's losing some part of its energy, or kinetic energy or potential energy, whatever you have read in physics. So when it's just hitting the deck, it's losing some part of energy, and it's not bouncing back to its original height, so it's losing some energy, and so as it bounces, the height decreases, you can see. So you should be careful enough to adjust the bounce, those handles, sorry, so that and over here the spacing is almost like equal on either part of the curve. See, it's almost equivalent, this space and this space. So and that's the that's why we have kept this handle a little far from this passing position or the breakdown position. See, if we bring back this handle, you can see this keyframe rising up, and it will be almost equivalent to this position. Let's see, if we grab X, see, it's rising up. It won't go like, okay, it's not going far enough, but still it would be better if we keep our handle, this handle, a little far from this passing position. That way we can have a good bouncing effect over here. Okay, that's done. Now what else? Okay, now I'll show you some real world examples, or real world rather images. Say, okay, so see, when you flip a coin, you see this spacing as a stratoscopic image, like a camera captures each frame and produce an image of overlapping images from each frame. Considering this camera captures the images as 24 fps. See, at the very top, at the crest, it overlaps, and when it's going from this position to this position, you see the spacing is this more, and it's getting less over here. You see the same thing over here. Right, you see it's less, it's more over here. Similarly, and about the balls, this is a basketball, and the same thing, like it's more over here, the spacing is more, this more, and it overlaps at the crest of the wave. So that's an example from the real world, and I'll show you some more example that I have already created. Let's press bouncing ball. Okay, first of all, I'll go to front view and just run the animation. Okay, see, this is a simple roll. This is rolling from A to B without any spacing. Now if I add one ball that is red colored, it's having some spacing, and see, it's easing out, and see, at the passing position, they meet at the same time. Just go to top view and see. So when they start, they are the same position, and the green ball moves at the same rate, while the red ball ease out and then pick up a velocity and moves at the passing position, and they meet at the same time at the passing position, and then ease in, and they reach their destination at the same time. So that's a very clear indication how ease out and ease in works. Now let's move back to this bouncing ball. Let's just go to front view and just review the animation. See, it's floating in air as if it doesn't have its weight. Now if we see this purple ball, it's having its weight. Okay, so this all we have seen. Now we will compare the two results and see. It's same thing as the previous example, like that they drop from the same height and they reach the passing position or the contact position at the same time. See, however, their spacing is different, or one having some spacing and one doesn't have it all. So see, and again they reach the crest at the same time. You see, again they reach the contact position at the same time, again they reach the crest, and so on. See, you can see it, right? Okay, now let's review this bounce and roll with weights and without weights, or with spacing and without spacing. See, they start from the same position, they hit the deck at the same time, and they again reach the crest at the same time, and again, and so on. So the yellow ball doesn't have spacing and doesn't look like it's having its weight, and thus it looks quite floaty. It's floating in the air. See, the yellow ball doesn't have its weight. Now let's see one more example, the last one. Okay, now this is, suppose this is a metal ball or like a cannonball. I'll just play black then. Okay. So it a heavy metal ball doesn't bounce too much, so it'll bounce quite a bit, and but see, they follow. Suppose the green one is a plastic volleyball and the black one is a metal cannonball, but look at they descend at the same rate. Heavy doesn't mean that the black ball will reach the ground or hit the deck earlier than the green ball, and that's very a very misconception among various people that a heavy ball will hit the ground much faster than the lighter one. That's not true, because I'll show you. Okay, it says if you tossed an object either up or down and could somehow eliminate the effects of air on its flight, you would find that the object accelerates downward at a certain constant rate. That rate is called free fall acceleration, and its magnitude is represented by g. The acceleration is independent of the object's characteristics such as mass, density, or shape. It is same for all objects. Okay, now you see this image, another stratoscopic image, and okay, for example, for feather and some bubble or air bubbles or balloon, it may not be very realistic doing of your own, but if we test under vacuum or in the absence of air, any object, irrespective of their weight, size or density or mass, they will fall at the same rate. They will hit the deck or hit the ground at the same time. See, the feather and the apple are the same, right? So that's the thing. A few more examples, like if I drop a ball, just I'll drop the ball, and if I just push a ball, they will descend at the same rate. However, their trajectory will differ. Similar here. This ball is having this particular trajectory, or I'll just enable this. Okay, and for this too. So the heavy ball follows this particular trajectory, and it's it doesn't go far enough and just hit, but they both descend at the same rate. That should be the main thing right here. Say, you see the difference? So what I have done is that I've kept the curve of this green ball and copied right there, but I have just manipulated the x-axis or the, just a minute. Okay, this particular thing I've just make a ghost of this. Okay, this is the curve for this green ball, this function curve. It just bounces right over there. However, if you see this, see they follow the same curve for this green curve, but once it hits the deck, the black ball, it just bounces 2 more times, and the bounce is not too much, just 1, 2, and very little bounce. And one more thing, that for the green ball, a green plastic ball, this the red curve is like it's going from here up to almost this position. However, for this metal ball, it's going from here up to here, like where it's just stops after like bouncing 2 more times and rolling a bit, and then it stops. So I'll just bring back this X curve from this position to this position and leave it there. So that's the difference between like a heavy metal ball and the plastic volleyball. So you can play around with this curve editor and can vary those curves and see how you can achieve different result, but make sure you keep your fundamentals right. So another example, this red ball is just dropped from this position and this white ball is pushed, but they follow they descend at the same rate. This white ball follows a trajectory path, however this ball straight away falls right here. Okay, we have seen this thing. You should always remember that the acceleration is independent of object's characteristics such as mass, density, or shape. It is same for all objects. Now you can either plan your animation by sketching. I have just got this very nice sketch from someone. I just can't remember who have done this. Say he even done the spacing thing very closely. Just see, it says increase spacing from here to here. Here it said it should spacing, even is asking, should spacing here be even between this and this position? And he says spacing should be same on both sides of the curve, like this particular spacing should be this equivalent to this spacing. However, see this, what I have said, the ball loses energy, make sure that it's lower than this particular key should be lower than this. You have drawn several other images right over here, for heavy ball and a light volleyball. So next time I'll try to do an exercise. Okay, someone have put like I don't know what's his name, Jindra. Okay, so I think it's animationmentor.com week 4 exercise. I'll try to do this exercise like two balls. One is a cannon metal ball and another is volleyball. They will be interacting with each other. Rather, like from here, from frame 1 to frame 25, it goes from this position to here, and then bounces 2-3 times and just roll over here. And when it hits this seesaw kind of thing, once it hits a ball is the volleyball is resting over, and once it hits this ball, the volleyball gets from this position to this position and there and then. So it will be interesting exercise to do, and I'll see how this turns to be. Okay, that's it. I have covered almost everything. So one more time I'll say just clear path, just okay, this position, like it starts from here and hits the deck here. So these positions, like the crest and the time when it hits the ground are called timing at this time, and this particular like the space between these two keyframe are called spacing. So let's see what Richard Williams have to say regarding timing and spacing. Timing, the rhythm of where things happen, where the accents or beats or hits happen. Same thing as we have done in our example. Okay, now what he have to say about spacing? Okay, in our example we have seen that the ball overlaps itself when it starts at the slower part of its arc, but when it drops fast, it's spaced further apart. That's the spacing. The spacing is how close or far apart those clusters are. Right, we have see this. The spacing thing is about the cluster of this thing, how far apart these keyframes are. Okay, just clear this path, and okay, this is just a simple bouncing ball with a bit of spacing. Now I'll just I have tried few more patterns. I've seen one of Animation Mentor's video that they have tried with different patterns, and let's see pattern ball roll. Before that, just okay, the dotted curve you see, that was from the previous, that's a simple bouncing ball, and now this is the one you see with clear curve is for pattern 1. I'm breaking the pattern right over here. It's bouncing the same height, and right here at the third bounce it goes little up. Let's review this animation. See, so breaking a pattern add a texture to your animation. Okay, it doesn't look very realistic because it doesn't have any real world physics, but it's a funny thing to do in animation. You have some liberty to do like you can break some rules. So one more pattern we'll see. It's a kind of a different curve. Like this, the crest is not right at the middle, but I have shifted towards right. See, for each of these crest position, I have shifted a bit toward. You can see. So when it's coming down, it's coming very fast. Duck, 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 duck. Okay, that's two patterns. Okay, I have done one more thing, that's with stress and stretch. Say when the ball is coming down, it stretches, and once it hits the ground, it squash, and again when it goes, it stretches again, and when it reaches at its crest, it regains its shape. So that's how a squash and stretch happens in animation. A simple example, but you shouldn't do much because it may look weird. You just need to add a subtle effect. Now let's review this animation. Okay, it's with a stretch and stretch effect. Okay, I'll just added few more keyframes for this squash and stretch because I'm just you can see in the background the dotted lines. That's from the simple bounce and roll effect, but I have added few more keyframes just to add the scaling factors. Like it start from its original shape, but as it descends, it stretches. You can see it's elongating along its path, and as soon as it hit the ground, it squashes. Okay, so you may try it, but the scaling factor is right here, I guess. Okay. Okay. Okay, these are the scaling curves you can see. So as it goes from left to right, the squashes and the stretch and squashes decreases because it's losing its energy, so it doesn't get too much squashed or stretched as it move along. So you have to check this particular thing as well. So if anyone is interested, can try out this. Okay, that's it for now. I think I have covered most of the things. So thank you. See you next time.